So this homework is going to go over CPCTC, which is something you should have seen before, but we're going to spend a little bit more time on that. It's one of our major focuses. So CPCTC means corresponding, that's the first C, so corresponding parts, so the P means parts, of congruent, that's your second C, triangles, that's your T, are congruent, and that is your last C. So if we look, we have a C, and then we have a P, a C, a T, and a C, a C. The corresponding parts of congruent triangles are congruent. Sounds pretty self-explanatory, but we have to prove those things. So there's a couple things that we have to remember. You always have to prove that the triangles are congruent first before you can prove that the parts are congruent. So sometimes you're given that, and sometimes you have to find out why. So let's remember, we can prove from a couple different ways we can prove triangles. A little note of different ways we can look. We know that we can do side, side, side. We can do side, angle, side. We can do angle, side, angle. We can do angle, angle, side, or hypotenuse leg. Okay, which we know that has to do with right triangles. All right, so let's talk about our first one. It says that given CAT is congruent to DOG. And we're going to list the angles inside of the triangles that are congruent. So I'm going to go ahead and mark what they're telling me. So they told me that CA and DO, because that's the right order, are congruent. So CA is congruent to DO. Okay, and then AT would be congruent to OG, and then our last piece are also going to be congruent. And so now let's think about our angles. If we're looking at in order, C is first, is congruent to D, so we're going to put one arc here and here, and A and O. If we think about stacking them, and this is a strategy a lot of people like to use, CAT over DOG, you can clearly see A and O go together. So A will get 2 arcs, O will get 2 arcs, and then T and G are stacked on top, so they'll get 3 arcs to show congruency. Now we can look at our sides. So because we use our little marks, we can easily say what is congruent. So the segment CA is congruent to DO. AT is congruent to OG. And CT is congruent to DG. And that's our sides. Now we can look at our angles. We look at just our arcs. So we have C and D. So angle, and you can do it this way. Some people do it that way. I do it a mix. C, angle, D, and then angle A to angle O, and angle T to angle G. So we proved first, we were given actually, that they were congruent triangles. And then because we knew they were congruent triangles, so this is our first part we have to prove, then we could prove that the sides were congruent and the angles were congruent. So the next example asks, are the following triangles congruent? If so, why? So it says triangle MAK is congruent to something by something. So remember, first we need to prove that the triangles are congruent, and so we're going to have to look to see if we have enough markings to tell us that. So we said MAK is congruent to something. So if we look closely and we see some corresponding parts, M has 1 arc. Well, V has 1 arc. So we could say triangle V. Let's see if we have more marks. So we went M, A. A does not have a mark at all, but that means it would correspond to L that does not have an arc at all. So V, L. And then K had 2 arcs, and 0 or O had 2 arcs. So V, L, O. So now we got to decide, how is that related? Well, we have some options. We know we have the side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So let's look what we have. We have, let's make some marks. We have an angle, we have an angle, and we have a side. So we know that we have 2 angles and a side. So if we look at our different ones, we have 2 angles. Well, that one's out, the second one's out. We have 2 angles in these. So it's one of these. So it's either angle, side, angle, or angle, angle, side. Now we've got to look and see what is close together. So if we look at our arcs, we say, we talk about our marked ones. We've got an angle here, and we have an arced angle here. So together, they're side by side, the 2 angles, and we just have one side here. So look at your side and ask yourself, is it touching only one marked arc, or is it touching 2? And if it was touching 2, this one down here would be marked. So we know it's only touching 1. So if we look here, this one is touching 2. This one is only touching 1. So we know this is angle, angle, side. Now that we've proven that they're congruent, we now can prove the congruent parts. So MAK, we're talking about the angle, MAK, so MAK, this angle right here, we got to say, what is it equal to? Well, it's got to go in the same order. And if you use the stack kind of method, we had MAK up here, and we had VLO that we've already determined they are congruent. So MAK has to be congruent to angle VLO. MKA, so MKA starts here. So M is congruent to V, K is congruent to O, and A is congruent to L. So angle VOL. Then we have line segment AM. So AM is here, and that's going to correspond to LV here. So now we have our congruent parts. Now if we look at our next example, it says, are the following triangles congruent? If so, why? We've got some parts marked, and so we've got triangle FED congruent to something by something. So let's go ahead and do the same type of thing and see what we have congruent-wise. So FED, so F, and I'm going to stack them over here to help us. So if we look first at F, F is here. It doesn't have anything marked. Nothing marked at all. So we know its angle, its corresponding angle is not going to have anything marked. Well, the only one that doesn't have anything marked over here is M. So M is going to correspond with F. Then we have E. Well, E is right here. And it shares 2 different ones. So we've got to think about how it's made. Okay? So when we think about how it's made, we're going to look at what it corresponds. Well, if we go flip to the other side, we have D. So we know that this is going to correspond, E is going to correspond to D. And then vice versa, D is going to correspond to E. E can't correspond to itself, and D can't correspond to itself. So we have triangle FED corresponds to triangle, or is congruent to, MDE. Now, let's see why. We have 1 arc, and we have 2 arc, and then we have a side. So we're then again to kind of what we had before. We had an angle, side, angle, and an angle, angle, side. We have 2 angles. We've got to decide what is going to work. Okay, so we have 2 angles. We're looking at the 2 pieces that we can prove angle, side, angle, or angle, angle, side. And we look at our side and we say, do they touch both of the angles? And they do. It touches this angle here, and it touches this angle here. Okay, so that's where they're going to be in the middle. So this is an angle, side, angle. Now we can compare our parts. And we've already kind of written up our pieces, and we're looking for angle FDE is congruent to what by something. So we're saying, how do we know it's congruent? So we're going to look, and we know once we find the normal proof, we then can prove this. If we look up at the previous one, we did these, and we proved it by CPCTC, congruent corresponding parts. So these are all going to be CPCTC. All of them, because that's what we do after we prove that it is a triangle. We prove its parts, its corresponding parts with the CPCTC. All right, so FDE, we correspond, F corresponds with M, so we know this is going to be angle M first. Then we had D, that means we're going to have E second, and then we had E, which means we're going to have D last. So angle MED. EF, so EF, here's EF, that corresponds to DM. And ME, because I did a little backwards on us, corresponds to FD. Okay, so stack method really can help. So we're going to make a couple notes about when do you stop and when do you keep going. So in our first couple examples, we proved first that a triangle was congruent to a triangle, and this is a normal proof. So when we're proving a triangle is congruent to a triangle, so triangle something is congruent to a triangle something, that's just a normal proof, and we stop there. If it then asks us, after we do that, to do corresponding parts or to prove that an angle is equal to an angle, kind of like these last two examples, we had to do an angle is equal to an angle, segments equal to a segment. So if we're proving an angle is congruent to an angle or a segment is congruent to a segment, we have to do an extra step, and we end that with the CPCTC. If we have to prove a word, so some type of definition, we have to do two extra steps. So we do our normal triangle, then we do the CPCTC, then we have to do a final step, and we have to end with the definition of the word. So we're going to do a couple of our examples that go into two-column proofs. So in two-column proofs, we're going to start with what we know, label some things, and then we're going to end with what they're asking us. So I'm going to start with what we're given first. So we are given a couple of important things. I'm going to go ahead and write them. So the first thing that we are given is that angle BAC is congruent to angle EDC, and this is a given. So let's go ahead and mark that. So we have BAC, and so this is talking about this angle here, is congruent to EDC. So that middle piece, that middle label there is our angle where our little arc is going to go. So we've got that one marked, and that's given. Our second thing that we're given is that C is the midpoint of BE, segment BE. So if we look at segment BE, we're talking about from here to here, C is our midpoint, okay? And that is given. Now, because we know the definition of midpoint, we can now get another set of information. We know that if C is the midpoint of BE, then that means that B to C and E to C are congruent. So our third statement we can make, based on our postulates and our rules, is BC, the segment, is congruent to EC, and that is because of the definition of midpoint. Now, we've got one angle that's the same. We've got now side to side. We can't prove with just a side and an angle. So we need either another side that we can prove, or we need some more angles that we can prove. Well, notice that when the C creates that midpoint, it also creates an X here. And when that happens, That's a vertical angle. So this angle here and this angle here are congruent because they're vertical angles. So we got to be careful about how we name these. We got to be very precise. Notice that C's in the middle. We can't just say angle C. That doesn't distinguish between the two triangles. We've got to do something very precise. And it doesn't matter what you put first, either B or A. You just have to do it consistently. I'm going to start with A. So I know that for 4, I have angle AC, C being in the middle, and B is congruent to, and I got to think about what is congruent to A. Well, it had one arc, and D has one arc, so I know that D is going to go first. C has to go in the middle, and then E at the end. So it is ACB is congruent to angle DCE because they are vertical angles. Forgot a letter there. Vertical angles. All right, now we've got 2 angles. So we got 1 arc, 2 arcs, and then we got a side. So we have 3 things that can help us prove what something is. And again, we're talking about, do we have side, side, side? Because we have to prove our triangle first. It's congruent. Side, angle, angle, side, angle, angle, side, or hypotenuse leg. Those are the only ways that we can prove that a triangles are congruent. So we've got to see what all do we have. Well, the first one we were given, we had some given information. We were given an angle. So this is an angle. We were given some information that helped us find the midpoint, which gave us some sides. So this gave us some sides. And then we used our vertical to find another angle. So we have angle, side, angle. So we have 2 angles and a side. Well, there's 2 angles and a side, and there's 2 angles and a side. So now we got to decide which one it is. So if we look at your side, one of your sides, and we're just looking at this one triangle, this triangle here, and we see we have a side, is it touching both of our angles or only one? Well, if it was touching both, we would have an arc right here, and we don't. It's only touching the one. So we know, because this one's only touching one, that it is an angle side. So we can rewrite now, number 5, we know that triangle, and I'm going to write them the same way as before, ACB is congruent to triangle DCE because of angle, side. And now it asks us, the last thing it asks us is to prove that segment AB is congruent to DE. So previously we talked about if we had to go one more step and prove an angle or a segment, our end would be CPCTC. So our last piece would be angle AB, or segment AB, so AB here is congruent to DE here. So we're talking here and here are congruent. And they're congruent because of CPCTC. Once we know our triangles are congruent, then we know our parts are also congruent. All right, example 2. We got some given information, so we're going to start with that. So our first thing is we're given segment AH is perpendicular to segment MT. That's given. So we'll make some marks there. If we've got AH and it's perpendicular, then we got to think about what that looks like. So AH is here, and it's perpendicular to MT. That means this angle here and this angle here are both right angles. Perpendicular makes right angles. So we got right angles. Now we're going to see what else is given. So we've got AM segment is congruent to AT, and that is given. So AM and AT, mark those are congruent. And it wants us to prove that angle or segment AH bisects angle MAT. So MAT when we think about MAT, we've got to find out that AH, which is this line, is bisecting that perfectly here. So we've got to do some other things. So the first thing we're going to do is think about our perpendicular, what we're given. So we know that angle, because we marked it, the angle that we have, because right now we have some sides. This gives us some sides right here, and this gives us, hopefully is going to give us an angle, but first we've got to get there. So we got to see what that angle is. And we got to do that by proving why is it a 90-degree angle. So number 3 is MHA, so MHA, so angle MHA and angle THA are right angles. And we know that because we know what the definition of perpendicular lines are. So we know that's why it made it right angles. We also know that because we have right angles, we also know that triangle MHA, notice my H is still in the middle, so triangle MHA and triangle THA are right triangles, because we know the definition of right triangles. Right triangles, three-sided shape, one angle has to be 90 degrees. We have that. We know the definition of right triangles. Now, we have to tell and get it in the same order to get some other pieces. So we right now have an angle, because we have those angles that tell us right here, this angle MHA is going to be a right angle. And so we have to now get those in the right order. When we think about AH, we can say AH, so AH can be considered congruent to HA. Okay, and that is because of reflexive property. All right, now we have some sides, because now if we know this is congruent, this one's also marked as congruent. We now have two sides and an angle. But we have a special type of two sides and an angle. We have a right angle. So anytime we have a right angle and we have these two sides, we actually can prove it by hypotenuse leg. So when hypotenuse leg, we have to have right angles, and we have that. So 6, we can now prove that these triangles are congruent. So triangle MHA is congruent to triangle THA because of hypotenuse leg. Now we have proven that they are congruent triangles. Now, that's not where we stop, because it asks us to prove that something bisects an angle. So we've got to look a little bit deeper. We know that to do an angle to an angle, we have to prove corresponding parts. And then we have some other things that we have to do to be able to prove the bisecting. So we have talked a little bit about some other angles, but we haven't talked about all the angles. So we don't have anything to do with the MAH. So up here, between here, and between here, we don't have anything there. I'll put two little things there. We need to prove that they're congruent, and they would be congruent because of corresponding parts of congruent triangles are congruent. So 7, we can say the angle MAH is congruent to angle TAH. Okay, and then we say the reason why is CPCTC. Now, we now are at our last piece. Remember before we had to do an extra step about bisecting? That extra step has to do with the definition of the word. So now we have to define what the definition of bisect is. And now because we know what we're looking for, we're saying AH, which was here, bisects angle MAT, and we know that because that's the definition of bisect, to cut in half. And we knew it was cut in half because these angles up here are identical that we knew from corresponding parts. So this is definition of angles that bisect. So our original to get just proven is kind of right here to prove our triangle, and then we had to go 2 extra steps in order to prove something's bisecting because that is a word, so we had to do 2 extra steps. Last one, on our last one here, we've got some given information. We're going to go ahead and start with writing it down. So we have our first, we're given that segment BG is parallel to segment WI. This is given. And now let's talk about what that looks like. So BG here being parallel to WI, we'll put our little marks there for parallel. And then BG is congruent to WI. And so congruence would mean that we get a mark here and here. And now when we're thinking about that, we also now have some other information to tell us that we have, because we're talking about something that was parallel, when we want to extend this out to kind of give you a visual. So if we're talking about these are parallel, and then we have a line that cuts through here, that's a transversal. So what happens with that transversal is we create alternate interior angles. And we can label whatever angles we want to either side. I'm going to label, use a color here, I'm going to label here and here, that would be congruent. Okay, and we also know that the other side would be congruent too, so we could have, you know, an angle. We could put 2 here and 2 on the other side. We don't necessarily need to right now. We're just talking about one particular set of angles, so I'm just going to focus on the one. So let's take our little lines away so we can see a little better. So now for number 3, we're going to start. I'm going to do, notice that we have to have it in the G here. If I'm doing BGI, I got to have the G in the middle. So I'm going to do angle BGI is congruent to angle. I would have to be in the middle over here because we're talking about this angle. W corresponds with the B across. So WIG. And those are congruent because of alternate interior angles. All right, so we've gotten a side taken care of, we've gotten angle taken care of. Now we got to figure out another side. Well, notice that because we have that transversal, the right here in the middle here, this is IG. That means that IG or GI is congruent to itself, so it's congruent to GI because of reflexive property. Okay, so now we actually have here, oh, I forgot to write given up there. We actually have here a side, we have an angle, and we have a side. So we have enough now to prove what type of triangle. So we can't just say because we ordered it side angle side that it's side angle side. It could be, we just got to look a little bit. So we have an angle and an angle, a side and a side, and then we have this side here, that's the same. And so we've got to look and see, based on what is marked, I'll take it away, based on what is marked, what do we see? So we have an angle, and it is in between a side It is in between a side and a side, so we know that this is side angle side. So number 5, we can say the triangle B, and I'm just going to name it the same as I did this angle a while ago, BGI is congruent to triangle WIG because of SAS. So there's our normal finish. Okay, now we are trying to get to something that being parallel. Now that's not a word, and those are not pieces. That's a converse. We'll talk about the rules of that in just a second. But before we get there, we need to prove our other angles. So, or at least another angle to be able to prove some parallel lines, because we're proving, or we're trying to prove, that BI is parallel to WG. So to do that, we got to have some other pieces in there. We actually have to have the proof of here and here. Okay, we have to have that proof. And we also have to have the proof of here and here. Now these outside ones aren't so very important as much as the ones that share on the parallel lines with our transversal, because transversals help with parallel lines. So our important to prove is actually angle BIG. So BIG, so this angle right here and this angle right here. So we'll say they're congruent, WGI, and make sure they're corresponding correctly because of CPCTC. Now that we've proven these angles on the other side of the transversals are congruent with alternate interior and CPCTC, we now can prove that BI segment is parallel to WG, and the reason we know that is because we have the converse theory. So we're going to use the converse of alternate interior angles. So we're going to make a couple of notes. So to prove parallel lines, or parallel lines after we've done our CPCTC, we have a couple reasons. It is either, so you have two choices. You have the converse of corresponding angles, or you have the converse of alternate interior angles. And so what that would look like if we're talking about corresponding, if we're thinking about corresponding, we're thinking about two things. We got our parallel lines. Corresponding would be, if we had this parallel and this parallel, we got corresponding lines here where we can put one on top of the other. And then you got kind of that Z-shaped. When you're talking about parallel lines here, you've got that transversal. Okay, so if you need to refresh those, what those converses are, that would be helpful if you get stuck with being able to have to explain parallel lines as your final information.